In today's presentation, we're going to talk about the support of the coexistence feature, both from the SAS point of view and from the Cambium devices point of view. In the first part of this presentation, we will discuss coexistence in general, what is the current behavior of the SAS, and how that will change with the introduction of this feature. And we will discuss in detail the two new coexistence parameters. In the second part of this presentation, we will show how to configure the new coexistence parameters both directly into the AP and also using the CBRS tool in cnMaestro. Until October 17, in the 3 GHz band, there was a mix of devices operating under Part 90 and other devices operating under Part 96. On October 17 of 2020, most of the Part 90 licenses expired, and now most devices operate under Part 96. This means that devices need to connect to the SAS to receive a grant, and the SAS authorizes grants only if there is no interference to higher tier devices. What are the higher tier devices? Today, the SAS only protects incumbents, which are the tier 1 users of the band. By the end of Q1 of 2021, the SAS will also protect PAL licenses, or better, the PPA, which is the PAL protection area, and these are the areas around devices that use the PAL license. In the protected areas, fewer channels are available for all the other devices, the GAA users, which means that congestion may be possible in crowded areas. As of today, the SAS does not coordinate spectrum usage across GAA devices, which means that interference is possible if channel coordination is not done offline ahead of time. Eventually, all the SAS vendors will support a feature where they can coordinate spectrum usage across GAA devices and assign the best channel to each device. However, this will be a long process and it will not happen in the near future. The first step in this direction is to collect the coexistence parameters. What are these coexistence parameters? They are parameters that give indication to the SAS on how spectrum can be reused or must be reused. They help the SAS answer questions like which devices need to operate on the same channel, which devices can share a channel, which devices do not interfere with each other, and which devices need to move to another channel together as a group. Eventually, all SAS vendors will support coexistence parameters, but the first out of the gate is the Google SAS, which already supports them now. The Federated Wireless and CommScope SASs are also expected to support these parameters later in 2021. As we will explain later, the changes in the AP GUI and in the cnMaestro tool to support the coexistence parameters apply to devices and accounts regardless of the SAS vendor the device is connected to. The coexistence parameters are collected and stored anyway. If the SAS supports them, then they are sent right away. If the SAS does not support them, then they are simply stored in the device or in the tool for future use. It is still worth configuring them, even if your SAS does not support them, because at one point the SAS will take the parameters and they can then be uploaded in bulk at that point. In order to take advantage of this new feature, operators need to upgrade both the radio software and the cnMaestro software. The radio software that supports coexistence parameters is release 20.0.1, and the corresponding cnMaestro software is release 2.4.2. Make sure you upgrade both of them. Of course, if you use cnMaestro Cloud, that will be automatically upgraded. If you're using the Google SAS, you can see channel recommendations directly in the Google portal. It is important to understand that those recommendations are based on default values if you don't provide your own, and the default values may or may not be relevant to your specific network configuration. If you haven't provided the coexistence parameters yet, we do not recommend you use the information from the Google portal. Make sure you first upgrade your devices and cnMaestro and you provide your own parameters. Let's now take a look at the two coexistence parameters. They are called Sector ID and Spectrum Reuse ID. These are names that Cambium has selected for these parameters, and they are unfortunately named differently across regulatory bodies, and some SAS vendors do not support them yet. and we don't know the exact names they will be using. So we are using our own names to be consistent over regulatory bodies and over SaaS vendors. Let's start with the sector ID. This is also known as Principal Subordinate Single Frequency Group, or SFG, in WinForum Release 2. It's also known as Common Channel Group, or CCG, in CBRS Alliance and in the Google SaaS portal in the channel ranking section, and same frequency in Google SaaS portal in the configuration section. The definition of the sector ID is a group of devices that must operate on the same channel. In fixed wireless application, this is one sector, meaning one AP and all the SMs that are connected to that AP. Both in the AP GUI and in the cnMaestro tool, the sector ID defaults to the AP MAC address. It is an editable parameter, but normally users do not need to change it, and we recommend leaving the default value. How will the SaaS use this sector ID parameter? When the SaaS calculates interference between devices in the same geographical area, they do not include interference contributions from devices within the same sector ID. If you have a number of SMs facing one AP and didn't provide the sector ID, the SaaS will not know these devices are part of the same sector. And since they operate on the same channel and they're facing each other, it will think that they interfere with each other. Of course, we know in fixed wireless this is not the case, and that is why it's so important to communicate to the SaaS which SMs are connected to which AP, so the SaaS knows that these devices can operate on the same channel. At one point in the future, the SaaS will also support a feature where it will be able to recommend an alternate channel if a grant is suspended or terminated. This is one case where the sector ID will be used, because the SaaS will try to keep all devices with the same sector ID together as a group, moving them from the original channel to the new channel. This is not supported yet, but if all the information is already gathered at the SaaS, once they enable the feature, they already know which devices need to be moved together. One place where we see the sector ID used today is the sorted spectrum inquiry for an SM in the Google portal. Regardless of the quality of each channel, the channel used by the AP with the same sector ID is moved to the top of the list, meaning that it is the top ranked, and it has a little CCG label next to it. CCG is the terminology used in CBRS Alliance and means Common Channel Group, which is the same thing as the sector ID. The sector ID is unique within an organization. This is actually true for both the coexistence parameters, not just the sector ID, but also the spectrum reuse ID, which we're going to look at in a moment. The SaaS is going to use the information only within your organization, within the devices that share the same user ID. If you accidentally use the same coexistence parameters as another operator, the SaaS will still look at these two groups as different groups, because from the SaaS point of view, they're under two different organizations, so they're still two different groups. Let's now talk about the second coexistence parameter, the spectrum reuse ID. This is also known as spectrum reuse in WinForum Release 2, Interference Coordination Group, or ICG, in CBRS Alliance, and frequency reuse in the Google SaaS portal in the configuration page. The definition of spectrum reuse ID is a group of devices that may be on the same channel, but they don't necessarily have to be on the same channel. In fixed wireless, these are sectors that can use the same frequency because they actually don't interfere with each other. For example, if two sectors are far enough that devices in one sector cannot hear the signal from devices in the other sector, then they can be with the same spectrum reuse ID. Or sectors may have an orientation away from each other, and that's why they don't interfere. Or you have used down tilt when installing devices, so now the footprint of each device does not overlap with the others. One typical example is APs installed back-to-back. You can configure them with the same spectrum reuse ID, which means that they can share a channel. You can still pick a different channel for the two sectors if you want, but the SaaS will know that they can also be on the same channel as there is timing coordination and isolation provided by the front-to-back ratio of the antenna. This parameter can be left empty, but if it's not provided, then the Google SAS is going to make some assumptions in its calculations, and these assumptions may or may not match with your network configuration. For this reason, we recommend you provide your own, so you're in control of what the SAS is using when doing the math. There is no default value for this parameter. The user needs to populate it based on the frequency planning. Let's take a look at an example of how to configure the spectrum reuse ID. Assume you have a network deployed, as in this picture, where you use 4 channels. Each tower has 4 APs facing 4 different directions. In one tower, you use 2 channels in an AB-AB pattern. In the adjacent tower, you use 2 different channels in a CD-CD pattern. Then in the next tower, you use again AB-AB, and so on. Before the use of the coexistence parameters, how did you do your frequency planning? You would pick 4 separate channels and assign each sector to one of these frequencies. The difference with coexistence parameters is that now you assign a spectrum reuse ID in addition to a specific frequency. The frequency planning itself is identical, but the additional step is to configure all sectors labeled A with the same spectrum reuse ID. Let's call it, for example, Group A. Then you configure all sectors labeled B with a different spectrum reuse ID, for example, Group B, and so on for groups C and D. You still assign a specific channel to each sector, but the SAS will eventually be able to move devices to other channels based on congestion, and the spectrum reuse ID indicates which sectors you had originally configured as sharing the same channel. How does the SAS use the spectrum reuse ID? When the SAS calculates interference between devices in the same geographical area, it does not consider the contribution to the interference given by devices within the same spectrum reuse ID. This is similar to what the SAS does for the sector ID, but the difference is that devices with the same sector ID must be on the same channel, while devices with the same spectrum reuse ID may or may not be on the same channel. If you configure 2 sectors with the same spectrum reuse ID but different channels, that is okay from the SAS point of view. At one point in the future, the SAS will be able to reallocate devices to channels if there is congestion, and at that point, the spectrum reuse ID will play an important role. The SAS will not force sectors with the same spectrum reuse ID to be on the same channel, but if there is congestion, it is likely that these devices will end up on the same channel, as the SAS knows they don't interfere with each other. If you look at the channel recommendations from the Google SAS, the channel used by other devices with the same spectrum reuse ID is not moved to the top of the list. However, because interference from devices within the same group is not accounted for, it is likely that the channel quality of that channel ends up being better, and the channel is likely to appear towards the top of the list, even if it's not forced to be at the top of the list. If there is another channel that is not used, that channel may be ranked the same or higher. There is no preference given to the channel used by devices with the same spectrum reuse ID.
The next 2 slides show the 2 new parameters on the AP or backhaul manager. When you first upgrade your AP to R20 or later, when the AP comes back after the upgrade, the first heartbeat request sent out will include the default sector ID, which is the MAC address of this radio, if you're using Google SAS. If you're using another SAS vendor, the parameters are stored for future use. The Google SAS will then overwrite the sector ID their software has pre-configured and clear out the reuse ID that their software has pre-configured. Now that your radio is up on R20 or later, we want to also populate the spectrum reuse ID. One way to do this is to add this directly into the GUI, click Save, and then perform a reboot. When the radio comes back up, the next heartbeat request will include the reuse ID, which will update the SAS. Another option would be to push a template from cnMaestro with that reuse ID. An example template is shown here. The template push will trigger a reboot of the AP. The template push is probably the quickest option to update lots of APs, since you could assemble just one template per reuse ID, then push that template out to all your APs that use that reuse ID in a single cnMaestro job. If you need the procedure for how to create and push a template, you can see the cnMaestro user guides on the Cambium product page or via the online help feature on cnMaestro. There is also a way of putting a variable into this template, which could be useful if you had a lot of different reuse IDs you're using. That's probably not necessary, assuming you only have a handful of reuse IDs, but if it's something that you're interested in, again, see the cnMaestro user guides. You can also change the sector ID if you wish, although it's not something we'd suggest. For most operators, the default MAC address would serve the purpose. So that's how you can easily add coexistence parameters to existing sectors without having to give up your grant and ask for a new one. So what we just did, we didn't change the frequency or bandwidth these sectors are operating on. The benefit of doing this is really for additional radios you will add in the future, as well as helping the SAS coordinate interference between you and other operators going forward. So for these last 6 slides, we'll walk through a basic example where we use the cnMaestro tool to add a new sector with coexistence parameters, register the AP, select our channel, and request the ERP values based on the spectrum and inquiry response, and then request our grants. This slide shows a summary of the major changes done on our cnMaestro CBRS management tool. Before this release, the tool's basic start operation went from a registration procedure directly to a grant procedure. It didn't include a spectrum inquiry request. There was a button to perform a spectrum inquiry, but it was just something you could do optionally on the side. It wasn't part of that basic start procedure. Now we want to use the spectrum inquiry response to make our channel and EIRP decisions. So after registration and a spectrum inquiry exchange, we pause to let the operator study the results of that inquiry response before making selections. Also, Google has advised us that it could take up to 8 hours for them to provide an optimal spectrum inquiry response based on the coexistence parameters sent in the registration request. So this pause point that I'll show you in a minute is provided with an 8-hour countdown timer to guide the operator on when to press ahead. So let's walk through this. So first, to add a new sector, you can use spreadsheet import or the add AP button, just like before, but with the EIRP bandwidth and center frequencies no longer entered in the sheet or in the add AP pop-up GUI. We can add the coexistence parameters at this point though. Similar to radio code, the sector ID will be populated by default, and we can add our spectrum reuse ID in here. And again, even though these coexistence parameters will currently only be sent to the Google SAS, it's still a good idea to enter them in for future use. They will be stored in cnMaestro and the AP if you're using a different SAS vendor. So you've added or imported a new AP, you've clicked on Start, and now the AP will be registered with the SAS and a spectrum inquiry request will be sent for this AP. When the spectrum inquiry response is received by the management tool, you'll see this large pop-up here, which is new to this code release. At the top, you'll see 2 graphs of the content of the spectrum inquiry response. It's presented in 2 different formats, sorted by rank or sorted by frequency, but it's the same information in both graphs. If the operator here wanted to select, for example, a 20 megahertz bandwidth, you can see 3560 through 3580 would be a poor choice. Those are ranked lowest by the SAS. They're ranked 14th and 15th by the SAS, indicating somebody else likely is using these channels in the area. 3550 to 3560 would be a clean choice. but that's only 10 megahertz of bandwidth. So an operator could select, for example, 3580 to 3600. When that selection is made, then the tool will shade those channels in blue in the second graph as shown here. And notice carefully this countdown timer that I mentioned before. I picked a channel here for demonstration purposes, but the Cambium and Google suggestion is to wait for this 8-hour timer to count down to 0, then send one more spectrum inquiry request, then see if the responses change before making a final selection. You can leave this window open and just click on this refresh button in the upper right-hand corner here to send a new spectrum inquiry request after the timer is counted down to 0. Or another option is to close out this pop-up with this little X here. The countdown timer will continue in the background. At a future point in time, you can again click on Start. Another spectrum inquiry exchange will take place, and you'll be back at this pop-up with whatever remains of the countdown timer. All these details are explained in the CBRS Consolidated Management Procedure Guide, and we'll have a link to that on an upcoming slide. For anybody using CommScope or federated wireless, the procedure is similar. You'll still go through a spectrum inquiry exchange and a pause here, but because they don't support ranking just yet, only the second of these two graphs will be shown. For federated wireless, what you'll see is a simple graph with available colors per 10 megahertz channel, but no max ERP values and no ranking numbers. For CommScope, you will get max ERP values per channel and ranking indicator numbers, but there is no sorting by CommScope, so the numbers are meaningless. They will always appear in ascending frequency order. Looking more closely at the center area of this pop-up, we can expand the Coexistence configuration section to see the sector ID and reuse ID we were working with. And then the Spectrum Reuse ID statistics table shows how many other Spectrum Reuse IDs in this account have grants associated with them. In this example here, we have 2 reuse IDs in this account that currently have grants, and the center frequencies and bandwidths are shown here. Looking at the bottom of that same Spectrum Inquiry pop-up GUI, after waiting 8 hours and getting a final spectrum inquiry exchange, an operator can confidently make their frequency and bandwidth selections as shown here, then click Calculate Max ERP. Requested ERP values can then be entered here per device. This SAS allowed total max ERP is a translation from the dBm per megahertz max ERP values provided in the inquiry response to a total ERP value we can use for guidance on what to enter for requested ERP. So while both these two max values happen to be 48 in this particular case, they are two different things. One of them is guidance from the SAS on how much they can be expected to grant, how much the SAS can be expected to grant in the bandwidth for the bandwidth and frequency selected, while the other is a limit based on the device model, antenna gain, and of course the bandwidth as well. So you've entered everything on that pop-up GUI and clicked on a Save button that was at the very bottom. Now the tool will go ahead and send a grant request for the registered AP while the SMs are registered in parallel. The remaining steps of the procedure are very similar to existing procedures. The cnMaestro redesign also involved a lot of changes and improvements to other CBS procedures. For more details on those changes, see our CBRS Consolidated Procedure Guide on either one of these links provided at the bottom of the slide.